developed for graphing a quadratic to help us find roots from a graph, and then to eventually translate those roots into solutions. Okay, so our objective in this first video is to describe the difference between a quadratic function and a quadratic equation, and then determine what is a root when I'm asked to find the roots. How do I find a root? And then how do I find roots from a table? And then we'll take these pieces and we'll put it together and we'll solve a quadratic by graphing. So let's pick our pen here before we advance, and let's get started. So we learned from lesson 5.1 that a quadratic function has an equation f of x equals ax squared plus bx plus c. From there, we found the vertex, we identified the coefficients a, b, and c, we decided if it opened up, down, all those kinds of things to help us graph it. Now, with a quadratic equation, the problem will be presented to you as 0 equals, or ax squared plus bx plus c equals 0. Okay, the 0 can be on either side. But basically, the f of x, or the y, is replaced with a 0. And it's asking us to find those x coordinates that have a y coordinate of 0. That's what it means to solve. To solve, find the x coordinates that have a y coordinate of 0. Okay? Now, before you start this whole process, you must make sure that you get your quadratic equation set to 0. It could mean that you have to move things to the other side of the equal sign, but you have to do that before you try and solve. Otherwise, things will go haywire. So the roots of an equation, those are the solutions. The solutions. They are x values, xy values, that have an x coordinate with a y coordinate of 0. Okay, you can also think of them as the ordered pairs where the graph crosses or touches the x-axis. They're also called solutions. We've said that up here. They're zeros of the function, and they're the x-intercepts of the graph. Okay, these are all interchangeable words for roots of an equation. Most of the time, we're going to get nice, pretty roots. But it could be that our graph doesn't cross at an integer. So what we're going to do, we're going to estimate the solutions until we learn some more techniques, and we're going to state the consecutive x's that the graph crosses between. Okay? And when we say crosses, it crosses the x-axis. Okay? All right. So we can just look at a graph and we can determine and state the solutions, okay? A quadratic equation can have one real solution, it can have two real solutions, or it can have no real solutions. And these are some examples of how it might look. One real solution is just going to touch the x-axis and then bounce back. It could open up or it could open down, okay? Right? This would be one solution. It touches and then turns back around and goes in back down or back up again. It could have two real solutions, as in this case of this example. Right? It crosses at 0, 0. It crosses at 4, 0. Those are two real solutions. Okay? It could also go upside down, and we could have something like this, where we would have a solution here and a solution here. And we would either state those or estimate those. Okay? The third option is no real solutions. We had one real solution, two real solutions, no real solutions. Notice how the graph misses the x-axis altogether. It doesn't even touch it. Okay? No touching at all. All right. It could also look like this, like it would be like above it. That would be no real solutions. All right, we can also look at a table Sometimes we'll make our own table, sometimes we'll be given a table, but we can tell where the solutions are from a table. So to do this, it's kind of like an order, just a process that you might want to follow. First, look for any y coordinates of 0. So here is a 0 and here is a 0, right? So these xy values are your roots. So we would have a root at 1, 0 and also at 4, 0. Those would be our exact roots. The next thing we can have is where it falls between two integers. So if you don't see any y values as 0, then start looking at your y values where they change signs. So it can go from positive to negative, like we have here, positive to negative. In order for my y value to be positive at x equals 1 and negative at x equals 2, then it had to go through 0 somewhere between it. So we would say we would have a root between x is 1 and 2. So we look at the y values, but we report the x values. We look for the y values to change sign, and we report the x values that it occurs between. All right? Can you see another pair where that changes from positive to negative or negative to positive? Hit pause, answer the video question, and then come back. All right, so look here. We go from -2, and then we bounce up to +4. That means that there had to be a 0 in between those. That means that we had to have a root between 3 and 4. And that's just basically how we say it. Roots between x values of 1 and 2 and 3 and 4. We don't know what the exact value is, the x value is, so that's how we report it. We'll find another way to do it, right? Third, you could have all of your y values have the exact same sign, okay? So notice how these are all positive. That means that this is my smallest y value and everything is above it. We could have all negatives and there would be no solutions, so there would be no roots. No solutions, no roots. All right, so go ahead and start watching the next video and we're going to put all of this into play.